All right, this is the Math 3, Unit 7, Rational Expressions and Equations Test Review. So work through these problems and show your work or explain your answers to get full credit when you turn this in after your test. So we're going to start with vocabulary. To prepare for the first 8 questions, go to Google Classroom, and there's a study set. So let me open that up for you to demonstrate. All right, under classwork, the vocabulary, I meant to put it here under vocabulary, but it is under assignments. I guess it's posted yesterday. So look for Math 7, or Unit 7, Math 3, Rational Equations, Vocabulary. I'll try to get that moved to the right spot. And then click, and then study that, review that study set. Rational Expressions and Equations. So it's a flashcard set. You can go through the definitions and the words. I have some pictures for some. Okay, you can flip the card over. You can zoom in on the picture. Okay, get a good understanding of that. Okay, we're going to be talking about equations, and we also refer to those as functions. Now we've seen this in Unit 2, so this is kind of a review, but it's thrown into this unit as well. So we're talking about shifting. How do those shifts and that function occur? And what does it look like when we graph it? Okay. Is this the right one? Yep, it sure is. So there's a lot to go through. Okay, make sure you go through those 24 definitions carefully, that you understand the terminology, and that will make the test much easier to approach. Okay, we're looking for the H values, K values, up and down. So this should be a review. So take some time to go through that before we go back to answering the questions from our review. All right, now we have this word bank. So read number 1. The blank value translates the function vertically up or down. So I've given each of you a set of notes. They look like this. It's just 2 different ways. I've printed it on the front, this way colorful, and then on the back, this comes from, the back is from the SAT Prep book. So whatever way that you like to look at this may be a little more detail on the SAT Prep side. But we've looked at functions, and now we're going to try to go back and talk about those transformation rules for functions. Okay, so let's look at question number 1. The blank value translates the function vertically up or down. All right, so I'm going to look here, and I see the words up or down. Okay, so in our parent function f of x, when we have a function and we add a value, and we refer to that value as k, or subtract a value k at the end, it's going to shift it. If it's positive, if we're adding, it's going to shift it that many units up. And if we're subtracting k, it's going to shift it that many units down. Okay, so this is our k value. Okay, so the k value translates the function vertically up or down. Number 2, one of the most important steps in solving rational equations involves multiplying all terms on both sides of the equation by the lowest common denominator, or least common multiple. So you can put lowest common, I'm going to abbreviate that, lowest common denominator, or you can say least common multiple, looking at the denominator. Okay, and we'll see that put into practice in some of these questions that come later. All right, question number 3. To solve a rational function division problem, you should flip the second term being divided into the numerator. if you remember your fraction rules, if we had something like 2/3 divided by 2/6, we would flip that second fraction and we would change this division to multiplication. So it would be 2/3 times 6/2. And then you could cancel out the 2's because 2/2 is 1. And then you could divide 3 into 6. And all you would be left with is 2/1. So division of fractions involves flipping the second term. So we flip that second term and then we multiply. All right, it's just the wording sometimes is confusing. All right, two separate curves of a rational function are called branches. So in rational functions, we can have asymptotes or holes. With asymptotes, let's just pretend we have an asymptote here, and it would be a dotted line. In fact, you wouldn't even see it on your graphing calculator. But you would see two branches approaching from opposite directions, but never touching that asymptote. So we call those branches. And we know that we have an asymptote when we have division by 0. All right, question number 5. The blank value translates the function horizontally left or right. Okay, so again, I'm going to look at my translation rules, and I gave you a copy of this. Okay, so we're looking at left and right. So if we have a value that we're adding or subtracting to our x, the k is not inside the parentheses being added or subtracted to the x. It's all the way at the end of the function. So if we have a number being added or subtracted to the x inside of the function, it's going to shift it. We call it h, and it's going to shift it the opposite of what it appears. In other words, if you see plus, I would assume that was moving to the right, but it's going to be the opposite. It's going to shift it horizontally to the left. And if I have minus, h is going to shift it horizontally to the right. All right, so the h value translates the function horizontally left or right. Okay, number 6, you cannot divide a numerator, that's the top of the fraction, by 0. That's division by 0. That's going to be undefined, and that's going to give us asymptotes that our graph approaches but never touches. Number 7, if the blank value is negative, it will result in the function being reflected across the x-axis. So I wrote this on the board, and I'm going to write it here in your notes if you want to copy it down. Okay, if we have a function f of x equals x, that's our parent function. Okay, now we said that if we add a number to the end called k, it's going to shift it vertically up or down. Now if we add or subtract a number inside of parentheses, we call that h, it's going to shift it left or right. Okay, the a value is going to be outside of the parentheses. In other words, we can be multiplying by a number, a fraction, positive number, negative number, the whole function, okay? And that would stretch it, shrink it, reflect it, all of these things, depending on whether that number a is greater than 1, less than 1, a fraction, negative, so forth. So if the a value is negative, it will result in the function being reflected across the x-axis. In other words, if you had a parabola like this, and you have a negative in front of the quadratic function, it would flip across the x-axis. Okay? Now, if you put that negative inside with the x, it's going to flip it across the y-axis. It's going to fold it across the y-axis. Okay? Number 8, a fraction is a blank of two numbers. So that's going to be a ratio of two numbers. So you can see we didn't use all of these. Some of them have different meanings. So make sure that you do study that Quizlet study set that you can find in our Google Classroom. All right, now let's go to part number 2, rational expressions. We want to simplify the expression below and circle the best answer. Okay, you want to look for, we may get an answer and our answer may be correct, but they may have it in a different form. So you've got to be able to understand how to find the best answer. All right, we're going to start with the numerator, and there's really nothing to simplify. Turn those lights back on. All right, so we're going to keep 2x on the top. I'm going to move down here so I'll have some room to work. So we'll start with 2x on the top, and then I'm going to look at the denominator, and I can see that 4 and 2 are divisible by 2. So I'm going to factor out a 2, and then I see that both terms have an x in them. So we're looking for the smallest exponent. This is x to the first power. I'll go ahead and write that in, even though we normally don't write that x to the first power. 1 is an identity and it's invisible. Okay, so we're looking for the smallest power for x's, and that's x to the first power. So these are both divisible by 2x, so we're going to factor out a 2x. Okay, now there are two terms that we're going to divide that 2x into. So the first one is 4x squared, and remember we factored out a 2x, so we're dividing a 2x into that first term. So 4 divided by 2 is 2, and then x squared divided by x to the first power is x to the first power, or 2 minus 1 is 1. Now we're going to move to that second term, and again we're dividing out a 2x. So we're going to take 2x divided by 2x, and that's simply going to be 1 over 1. Any number over itself is 1. Okay, so we factored the denominator. The numerator didn't need to be factored. And then we can see that 2x and 2x are the same thing. Any number over itself is 1. We can't leave this numerator blank. We have to put a 1 here. So our answer is 1 over 2x plus 1. Now let's look and see if we have a match, and we do, with answer choice D. Now if you do this by trying to divide 2 into 4 right here and just splitting it up without factoring it first, you're going to get confused. So make sure that everything is factored before we start working these problems. Okay, question number 10. Okay, this is already factored in the numerator. I only have to factor the denominator. This is a quadratic equation, and I have a coefficient of 1 right here. Again, 1 is invisible. So I want the factors of 18 that multiply to give me 18, but add to give me 9. And all of these are positive, so my factors are going to all be positive. So I'm going to start with 1 times 18. I want whole numbers. Okay, 1 times 18 is 18, but 1 plus 18 is 19, and that's not what I'm looking for. So now I'm going to go up to 2. I'm going to divide 2 into 18. 2 goes into 18 9 times. Now 9 times 2 is 18, but 9 plus 2 is 11, and I'm looking for 9, so that doesn't work. Are there any other factors? Let's move up to 3. 3 goes into 18 6 times. 6 times 3 is 18. 6 plus 3 is 9. So these are the factors that I'm looking for, and I can break this into 2 binomials, x plus 3 and x plus 6. Okay, so that's the denominator. We still have the numerator. Let me rewrite that as x plus 3. Just put that over here so we can see it. And we still have x plus 6. And then the denominator we factored into x plus 3 times x plus 6. Okay, now these are the same things. X plus 3 over x plus 3 is just 1, and x plus 6 over x plus 6 is just 1. 1 times 1 is 1. Now this is one approach. Another student told me that they multiplied these two together, and x times x, you can use the box method or you can use the FOIL to distribute multiplication of these two terms to both terms here. and you would still get x times x is x squared, 3x plus 6x is 9x, and then 6 times 3 is 18. So they discovered that by multiplying, you could see that these are the same numbers, same things, okay, and that would equal 1 as well. So there are two approaches to this. There's often not just one way to solve it. All right, so for number 11, we're going to factor the numerator, and I can see that I can divide out of 2. But both of these terms don't have an x in them, so I can only divide 2 into 4 into 4x, and you're left with 2x. There's plus in between those terms. Divide 2 into 16, and you get 8. Okay, let me check. 2 times 2x is 4x, and 2 times 8 is 16. So that is correct. Now I'm going to factor the bottom the way we factored over here. So I'm going to factor 12 into 2 factors that multiply to give me 12 and add to give me 7. So I start with 1 times 12. Now that does not work. 12 plus 1 is 13. Then I go to 2 times 6. 6 plus 2 is 8. That doesn't work. And then I go to 3 times 4. And 3 times 4 is 12. But I'm not multiplying, I'm adding. 4 plus 3 is 7, and that's what I'm looking for. So I have my factors right here. X plus 3 times x plus 4. So that's going to be my denominator. X plus 3 times x plus 4. Now I'm doing a second look here, and I divided 2 out, but I can divide more than 2. I can divide 2 into both of these terms again. So let's take another 2 out. Okay, 2x divided by 2 is just x, and 8 divided by 2 is 4. So this gives us x plus 4. So in the beginning, I should have seen I'm dividing by 4. 2 times 2 is 4. Divide out of 4, and you're left with x plus 4. All right, so now that we have this completely factored, I can see the x plus 4 over x plus 4 is 1. So 1 times 4 is 4, and 1 times x plus 3 is x plus 3. So it's 4 over x plus 3. Okay, let's look at number 12. I've already done the work here, so let me just walk you through this. All right, we do have a common denominator, and we need a common denominator when we're adding or subtracting. All right, so we're going to start with that common denominator, and I'm going to write it down here, x plus 1. So the key is to take the numerators, start with 3x. Let me just rewrite what I marked through here underneath. We're going to start with 3x. And then we're going to subtract, because we have subtraction in between, 3x minus 5. Now I'm going to put parentheses around there to show you that we have to subtract both of those terms. We have to distribute that negative to both terms. So we're going to be subtracting 3x, so it's 3x minus 3x. And we're going to be subtracting a negative 5. When you subtract a negative, it becomes a positive 5. Now all that over that common denominator of x plus 1. So 3x minus 3x is 0. All we're left with on the top is 5. And then our common denominator is x plus 1. So our answer is 5 over x plus 1. All right, now let's look at question number 13. Okay, now I'm looking at the denominators that I've highlighted, and they're different. Okay, let's look at that smaller one, and it's 2 times x. Okay, I need to make 2x and 4x squared minus 8x the same number. Let me start over. So that I don't confuse you with my writing. So which one was it? It was question number 13? Yes. All right. All right, so I'm going to highlight the denominators, and I can see that they're not the same this time. All right, so before we start looking at the denominators, let's simplify this part of this fraction, this ratio. All right, I can factor out a 2 in the numerator. So 2x divided by 2 is x. Okay, take that 2 out, we have x left. Minus, now we're going to divide 4 by 2 because we're factoring that out. 4 divided by 2 is 2. So we factored the numerator. Now let's factor the denominator. Now notice there's a 4 and an 8. This time let's factor out the 4. We can take a 4 out, and there's an x squared and an x. So the lowest power is 1. So they both have an x to the first power. So we're going to factor out a 4x out of both terms. So in other words, we're dividing by 4x. So we start with 4x squared. Let's divide by 4x. That's factoring it out. The x and x squared over x. We have 2 here and 1 here, so this cancels, and we have 1 left on the top. 2 minus 1 is 1. 4 over 4 is 1. So we're just left with x. 4x times x is x squared. Now we're going to divide negative 8. We're dividing out 4x. Okay, negative 8 divided by 4 is negative 2. And there was an x up here to start with, I forgot, and then x over x is 1. So we're just left with negative 2. Okay, so we divided a 4x out, we're left with x. Divided a 4x out here, and we're left with negative 2. Now I can see that it's factored. X minus 2 over x minus 2 is 1. And then 2 goes into 2, 1, and 2 goes into 4 2 times. So the numerator of this part, this fractional part here, is 1, and the denominator is 2x. So when we simplify this, we get 1 over 2x plus 3 over 2x. Now I'm kind of relieved because I have a common denominator. I don't have to try to find a common denominator. Okay, so the common denominator, we're just going to write it as 2x, and then 3 plus 1, add the numerators, is 4. Okay, now we need to look again, and 2 goes into 2 once, and 2 goes into 4 twice. So our answer is 2 over 1x, or 2 over x. Okay. This can also be written as 1 over x times 2. You just have to keep that x in the denominator. So look for anything that might not be exactly this, but this is the right answer, but just written in a different form. All right, number 14, multiply or divide. So I like multiplication, it's straightforward. Before we start, we need to make sure numerator and denominator are factored, and this is already factored for us. So we're just going to put everything, multiply everything in the numerator and multiply everything in the denominator. Now I'm looking for common factors in the numerator and denominator. Pair them up. X minus 3 over x minus 3 is 1, so that cancels. And then 2 goes into 2 once, 2 goes into 4 twice. And I don't see an x plus 6 in the bottom. So on the top in the numerator, I'm left with x plus 6 times 1, which is just x plus 6. In the denominator, I'm left with 2 times 2. 2 times 2 is 4. So the answer here is going to be x plus 6 over 4. Now they could also rewrite this as x over 4. You can distribute the division into both terms, split it apart, plus 6 over 4. And then we would have to simplify 6 over 4 dividing by 2 over 2, which is just dividing by 1, and you would get 3 over 2. So it could also be x over 4 plus 3 over 2. This is the answer that I came up with, and that's the answer I'm going to first look for. All right, question number 15. I need to factor this. The right side is factored, so I just need to factor the left-hand fraction, this fraction right here. So I'm looking for factors of 2 that add to 3. So over here, the only factors of 2, and they're positive because this is positive, are 1 and 2. And 1 and 2 add to 3. So this factors into x plus 1 times x plus 2. Over, now I need to break down 12, factor 12 into two numbers that add together to give me a negative 7. So they have to multiply to give me a positive 12, but add to give me a negative 7. So both of my factors need to be negative. Negative 1 times negative 12 add to negative 13. That won't work. I'm looking for negative 7. Negative 2 times negative 6 multiply to give me positive 12, but add to give me negative 8, and that's not negative 7. Negative 3 times negative 4 multiply to give me a positive 12, and they do add together to give me a negative 7. So I found my factors here. So this factors into x minus 3 times x minus 4. Now we're operating with division. In division, we change to multiplication, and we flip this. Because this is already factored, all I have to do is put the denominator, write the denominator as the numerator. So x minus 3 times x plus 3, and then put the numerator as the denominator over x plus 1 times x minus 1. And then this is all multiplication. So let's draw one big line, and let's start looking for pairs that we can cancel or mark out. X plus 1 over x plus 1 is just 1. And do I have an x plus 2 in the denominator? I don't. Do I have an x minus 3 in the denominator? I do. Do I have an x plus 3 in the denominator? I don't. So in the numerator, I'm left with x plus 2 times x plus 3. In the denominator, I'm left with x minus 4 times x minus 1. Now you might see your answer like this, but I suspect that they're probably going to have this multiplied out and put it in standard form. So you might want to look for this answer. So multiply the first, and you can put this in a rectangle. A lot of you have used rectangles for multiplication. X plus 2 and x plus 3 will give you x squared, 2 times x, 3 times x, and then 3 times 2. And then you would still get x squared on the top, plus 3 plus 2 is 5x, plus 6, and then in the denominator you would get, I'm just going to FOIL this, x squared plus negative 4 plus negative 1 is negative 5x, and then negative 4 times 1 is positive 4. So it could be written this way, or it could be written this way once you've simplified it. Question number 16, we want to solve these rational equations. So we can cross multiply, and we can set up an equation that we can solve. I can see this is going to be linear. I don't have any squared terms, and I'm not going to be multiplying to get any squared terms. So go across in any order, up or down. I usually start at the bottom and go up. It's just a habit of mine, but I can start at the top and go down. 4 times x plus 3, and then separate that with an equal sign. And then let's take the other wing. 3x times 1. Okay, 4 times x plus 3, you need to distribute that and get 4x plus 4 times 3 is 12 equals 3x times 1 is 3x. All right, now I'm going to move my x's on the left and my constants on the right. It's not quadratic, or it's not cubic or anything higher than degree 1. It's linear, so I'm going to move all of my x's on the left by subtracting 3x from both sides. 4x minus 3x is 1x. Still have the plus 12. Bring down the equal. 3x minus 3x is 0. Now we're going to move that constant to the right, so I'm going to subtract 12 from both sides. Bring down the x. 12 minus 12 is 0. Bring down the equal. 0 minus 12 is negative 12. So your answer is negative 12. And remember, you always want to plug your answers back into the original equation and see if you have an extraneous solution. And I'm not going to give you any that have extraneous solutions on this test, but on the EOC you need to look for extraneous solutions. Okay, because rational functions could have extraneous solutions. For example, if we got x is equal to negative 3, that would be extraneous. Or if x equals 0, because we can't divide by 0. All right, for this one we need to simplify the left-hand side, so we need a common denominator. Okay, we have a denominator of x here, and we have to multiply that by x minus 3 because the denominator here is x minus 3. Okay, we're going to leave it in factored form. So 7 over x, we need to change that x to x times x minus 3. So we've got to multiply the bottom by x minus 3. And we need to multiply the top by x minus 3. This keeps it balanced because this is just 1. Multiplying by 1 doesn't change anything. So we have a common denominator if we do this. And then we take this second part, the 2 over x minus 3, and multiply that by, what are we missing? We're missing the x. Multiply by x over x. Okay, now let's simplify this and then try to combine the left-hand side. So on this numerator we have 7x minus 21, okay, minus 2 times x, or 2x, all over, and we have a common denominator, so let's write that x times x minus 3 as our common denominator. So we've simplified the left-hand side. That's what this is when we simplify it. Okay, now let's write equal and then put 6 over x. Now let's see if we can simplify this numerator anymore. So we have 7x minus 21, and then we had minus 2x, and we found that common denominator. So 7x minus 2x is 5x minus 21 over x times x minus 3 equals 6 over x. Okay, now we're going to do what we did in question 16. We're going to cross multiply. I may need more paper, so let me get some more paper. Alright, so we have x times 5x minus 21, and we cross multiply this wing, equal to, now let's take this wing and multiply, 6 times x minus 3. So that 6 times x is just 6x, and then times x minus 3. Alright, now let's distribute this x to both terms. So 5x times x is 5x squared minus 21x is equal to 6x times x is 6x squared minus 3 times 6 is 18, and don't forget that x. Now I see that I have a quadratic, so that means I'm going to move everything over to the left or to the right, but just make sure that one side has all of your numbers, okay? Even numbers that are constants. I don't see any constants, but we'll move everything over to the left, and then we'll try to solve. So let me subtract 6x squared for both sides. That's going to make that 0 right here. And I'm going to add 18x to both sides, and that's going to make that 0 here. So on the right hand side I have 0, and I added 18x to both sides, so let me not forget to do that to the left hand side as well. Alright, negative 6x squared plus 5x squared is negative x squared, and then negative 21 plus 18 is negative 3x. Now I don't want to start with a negative x. So let me factor out a negative 1 from all of those, or divide everything by a negative 1, or multiply everything by a negative 1, which is basically changing the signs of every term. So this is the same as x squared plus 3x equal 0. Okay, so now we need to factor it. We don't have that constant term, but I do have an x in both of these terms, so I'm going to divide an x out. When you divide x squared by x, you're left with x, plus when you divide 3x by x, you're left with 3. And that's as much as I can factor. So we're going to set x equal to 0, and then we're going to set x plus 3 equal to 0. This one I have to solve, so subtract 3 from both sides. X is equal to negative 3, and x is equal to 0. So you have two solutions, okay, that you want to plug into this equation and see if there are any extraneous solutions. And there aren't. I promised you that I wouldn't give you any that are, so we're just going to go with these two. All right, question number 16. Did we do question number 16? Let me look. Yes, we just did question number 16. All right, now we're doing combined work problems. Give me just a minute to get a blank sheet. All right, combined work problems. If Eric can shovel the driveway in 3 hours, so here's Eric's rate, 1 driveway in 3 hours, and Caden can shovel the driveway, so that's 1 driveway in 2 hours, how long will it take them to shovel the driveway working together? All right, so let's write Eric's rate, or his ratio. Okay, 1 driveway in 3 hours. So on the top, we've got driveway, and on the bottom, we have hours. Okay, we're going to set up Caden's ratio, same driveway, so 1 driveway in 2 hours. Drive and hours. Now we're going to calculate this by adding these two together because they're working together. So 1/3 plus 1/2 is equal to, we need a common denominator. Okay, 3 times 2 is 6. So our common denominator is 6. To get 3 to turn into 6, we have to multiply by 2. Whatever we multiply on the bottom, we have to multiply on the top. Okay, because 2 over 2 is 1. So 1/3 becomes 2/6. To get 2 to change to 6, we multiply by 3. Whatever we multiply on the bottom, we have to multiply on the top. 3 times 1 is 3, 2 times 3 is 6. So now we have a common denominator, 6, add the numerators, 3 plus 2 is 5. So we got 5, 6, but that doesn't answer the question. It says, how long will it take them to shovel the driveway working together? So if you remember, we're keeping this straight by putting driveways on the top. I shortened it to drive. I put driveway here. And hours on the bottom. We want to know how long it takes them to shovel one driveway, the driveway, working together. So we need a common ratio where we have one driveway on the top. And we don't know how many hours that is, so we're going to use a variable. Let's just use x. So now we have this set up, we can cross multiply. 5 times x is equal to 6 times 1. Divide both sides by 5. X is equal to 6/5. Now, does that answer our question? How long does it take them to shovel the driveway? If I say 6/5 of an hour, nobody's going to understand that. So we're going to reduce this. 6 divided by 5. You can use your calculator if you want, or you can do it by hand. 6 divided by 5. 5 goes into 6 one time with one remainder, so it's 1 1/5. Okay, if you use a calculator, let's see what that would look like. 6 divided by 5. So let's use Desmos. Six divided by 5 is 1.2. Let me get my problem back here. Where is it? Here it is. Alright, so 6 divided by 5 is 1 1/5, or if you use a calculator, it's 1.2. Now, we still didn't answer the question, how long will it take them working together? So 1 stands for 1 hour, and then we're going to take 1/5 of how many minutes there are in an hour. There are 60 minutes in an hour. So 60 divided by 5, you can get your calculator out again. 60 divided by 5 is 12. Goes into 60, 12. So 1 hour and 12 minutes. Now if you multiply 60 times 2/10, you're still going to get 12 minutes. So it's 1 hour and 12 minutes. All right, let's try another one. Natalie needs 4 hours to paint a room. Emma needs 3 hours to do the same job. So 1 room in 4 hours, that's Natalie's rate, and Emma's rate is 1 room in 3 hours. So let's add those together. We need a common denominator, okay? Now I'm looking at these two. We have factors of 2 times 2, and this one has factors of 3 times 1. So let's multiply those together. Our lowest common denominator is 12. All right, to make this 12, we've got to multiply by 3, so we've got to multiply the numerator by 3. So 1/4 is the same as 3/12. We need to change 3 to 12, so we need to multiply by 4 to get that common denominator. If we multiply the numerator by 4, we've got to multiply the denominator by 4. So this becomes 4/12 plus 3/12 is 7/12. So that's how long it will take them combined. But I didn't mark what this ratio is. This is rooms per hour, so this is going to be rooms per hour. Okay, now I need 1 room. I need to know how many hours. Okay, cross multiply. 7x is equal to 12 times 1, 12. Divide both sides by 7. X is equal to 12 over 7, or 1, 7, 8, 9, 10, 11, 12, 1 and 5/7. Okay? All right, now same thing. We're still working with hours. So we've got 1 hour. We need to know how many minutes we have. So 5/7 times 60 over 1. Okay. And you can do that on your calculator. Let me go ahead and minimize this. 5/7 times 60. So 60 times 5/7 is, we need to round that off, and I'm going to round that up to 43 seconds. So 1 hour and 43 seconds. All right, question number 19. Now we're going back to our transformations. So we have an equation, we have a function, and you can see that we are multiplying by a negative. Now we don't see that 1, but that's a -1. So this is going to flip across the x-axis. Adding that 4 is going to move it vertically up 4, and then subtracting the 6 here is going to move it horizontally to the right 6. It's going to be the opposite of what it appears, okay? All right, so that's what's going to happen. What are the values of A? A is -1. H goes with the x, so H is -6. And K is going to be that constant at the end, so that's going to be +4. So let's describe again the transformation movements of the function. So it's going to flip across the x-axis. Okay, and the H moves it horizontally. Horizontal 6 units to the right. It's -6, but it's going to be the opposite of what you would think. It's going to move to the right. If it's positive, it moves to the left for H. And then it's going to move vertically 4 units up. All right, now we can graph that, and the easiest thing to do is put this in your calculator and then plot the points. But you can start with your parent function and then go from there, but the easiest thing to do, let me pull up your calculator again, is to put that function in. F of x equal 3 over x minus 6. And just watch this carefully. Make sure that you are putting parentheses around the right things if you need to. You don't want this to twist around while you're not watching. All right, so I think I have it in correctly. I have it entered in correctly. All right, so here it's going to cross the y-axis at 0, 3.5. So I'm going to find that 0, 3.5, and I'm going to plot that point. And then my asymptote, if you look, we have x minus 6. Set x minus 6 equal to 0 and solve for x. And so you'll get x is equal to 6. So you'll have a line going through 6 on the x-axis vertically up and down, where these two branches will approach that but never touch that asymptote, that vertical asymptote. Okay? All right, so the last thing to do would be, to plot your asymptote. And our asymptote is going to be a dotted line. It might help if you have some colors in here. And then look at your graph. You will be able to use a calculator on your test. It's going to go through at 3.5, 0, 3.5. And where does it go through here? At 5 1/4, 0. Okay, so I'm going to find 5. Here's 4, here's 5 1/2 is here, 5 1/4, 0. So it's going to go like this, I think. I keep forgetting. Let me go back. No, it's going to go down. It's going to go like this. It's never going to touch that asymptote. Okay, and up here it's going to do something similar, but it's going to be the opposite like that. Okay, so you'll just sketch that in. And that's it. All right, good luck on tomorrow's test. Hope y'all all make 100.